This table is given to, and calculator is allowed for this one. So the temperature of coffee in a cup at time t is modeled by decreasing differentiable function c. It is decreasing. We can see it's going from 100 to 85 to 69 to 55. For 0 to 12, yeah, time is starting at 0 and it is going up to 12. Okay. Selected values of C of t are given in the table shown. Approximate C derivative of 5 using the average rate of change of C over the interval 3 to 7. Show the work that leads to your answer and include units of measurement. Okay, so they want to find out C derivative of 5 using average rate of change. So question number 1, part A. Here. So at 3, the value is 85. So if we talk about average rate of change, I will write OAORC, average rate of change is f of b minus f of a divided by b minus a. Over here, b is 7, a is 3, because 5 lies in between 3 and 7. That is why we are using the average rate of change. Now f of b is given as 85. F of a is given as, sorry, f of a is 85 and f of b is 69. This is 69 and this is 85. So now we'll find, and this average rate of change is equal to C derivative of 5. And this will be C of B. Yeah, the function is C, not F. So instead of F, we'll be using C. C of B minus C of A, C of B, C of A. So C derivative of 5 will be C of B is 69. C of A is 85. 7 minus 3. And now because calculator is allowed, I will just go to Desmos. It's over here. And I will just do this calculation over there. So all we have to do is 69 minus 85. And we're dividing this by 7 minus 3, which is 4. So you can see the derivative is negative 4. And let me over here you can see it is negative 4. All right. So C derivative of 5 is equal to negative 4. You also have to write the units because it is clearly mentioned in the question that you have to show the work that leads to your answer and include units of measure. If you do not include units of measure, then you will not get full marks. So for C, the unit is degree Celsius, and this is C derivative, that is dC over dt. So it will be degree Celsius per minute. So C derivative of 5, the full answer is going to be negative 4 degree Celsius per minute. So this is our answer. I'm going to write it over here. C derivative of 5 is equal to negative 4 degrees Celsius per minute. And this is our answer for the first part. Now the second one. Use a left Riemann sum with 3 subintervals indicated by data in the table to approximate the okay, so this is the entire B part. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the value of 0 to 12 C of t dt and interpret the meaning of 1 over 12 integration 0 to 12 ct dt in the context of the problem. So we have to use left Riemann sum. Okay. And so in left Riemann sum, we take the leftmost values. All right. So now I'll need the table. So I'll go back and see the table. Yeah. So integrate left Riemann sum. If this is the curve, you take the left value and make your rectangles. Got it? This is left Riemann sum. I've just told you what it is. So over here, you're going from 0 to 12. This is your length and this is your width. So they are rectangles and you're finding the areas of the rectangles and adding them together. So over here, it will be equal to, so the first width you can see it is from 0 to 3. And the length is 100 because at 0, the value of the function is 100. So the height or the length is going to be 100. So 3 minus 0 times 100 plus. Next is 7 minus 3 because the width is of 4. Because from 3 you're going to 7. So width is 7 minus 3. Length is going to be 85 because we're talking about left Riemann sum. We'll be taking the leftmost left value. That is 85. Next, the values are between 7 to 12. And they're saying 3 subintervals. So yeah, there are 3 subintervals. The first one is from 0 to 3. Second one is from 3 to 7. And the third one is from 7 to 12. So we will do 12 minus 7. And we'll multiply this with 69 because at 7, the value is 69. So that is the left value. So the approximate value is going to be 3 minus 0 times 100 plus 7 minus 3 times 85 plus 12 minus 7 times 69. Because calculator is allowed, so we'll just use a calculator to get our answers. And actually, just give me a second. I want to erase this and write everything in one go. So 3 minus 0 multiplied by 100. 7 minus 3 multiplied by 85. And 12 minus 7 multiplied by 69. 100, 85, 69. 3 minus 0, 7 minus 3, 12 minus 7. Perfect. And here I will explain to you. So we have 0, 3, 7, and 12. Here we are going to make length of 100. This will be 3. Then it is becoming 85. So this is going to be 85. And this is 4. And then 69. And this is 5. So yeah, now we'll just use Desmos. And again, because we're just doing calculation so that you can see in a better way, I'm going to make it bigger. And I'm going to place it over here so that you can see the entire calculation. So 3 minus 0 is 3. 3 times 100 is 300. Plus 7 minus 3 is 4. 4 times 85. Plus 12 minus 7 is 5 times 69. So the answer is 985. If you want, if you're not sure, you can also write 7 minus 3. And here also you can write 12 minus 7. We'll still get 985. So this answer is 985. Okay. Now I'll just remove the calculator. And this is 985. And in this particular question, they're not asking for units, so you do not need to write the units. Hmm. So 985. That is the sum. The next thing we have to find is 1 over 12. Yeah. 1 over 12 integration 0 to 12 ct dt in the context of the problem. So now 0 to 12 ct dt is actually summation, right? Integration is a limiting sum. So what you're doing, you're adding all the values and you're dividing by the number of values because the total interval is 12. So that will give you the average or the mean value. So 1 over 12 integration 0 to 12 ct dt. The value is going to be 985 over 12. We'll find this using calculator. And this indicates average temperature in degrees Celsius. And let me write temperature fully. Average temperature in degrees Celsius over the interval 0 to 12 minutes. So writing interval is also very important because in which interval you're getting the average temperature, right? So you're getting it from 0 to 12. And this becomes our final answer. This indicates average temperature in degrees Celsius over the interval from 0 to 12 minutes. So 1 over 12 and integration, that just gives you the average because integration is nothing but sum. So now we'll just find the value 985 divided by 12. So for that again, I'll be using Desmos. And this time we will be doing 985 divided by 12. It is 82.0833. So we can write it 82.08 degrees Celsius. So 82.08 degrees Celsius is the average temperature over the interval from 0 to 12 minutes. And with this, we have done everything for part B. So for part B, it is important that you find left Riemann sum, and to write its interpretation, it is important to include the keywords average temperature and the interval from 0 to 12 minutes. Now we'll do the C part. Yeah. So now what is the C part asking? It is telling us that from 12 to 20. So from 0 to 12, the table was given, but from 12 to 20, they have given us the equation. They are saying that C derivative of t is negative 24.55 e to the power 0.01 t divided by t. And C derivative of t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t is equal to 20. Show the setup for your calculations. Okay. So integration of C derivative is going to be just C. Okay. So from there, because it is a C derivative is given from 12 to 20, and it is negative 24.55 e to the power 0.01 t over t, and t is going from 20 to 12. So if you integrate this, After integration, writing dt is very important. That will be equal to c of 20 minus c of 12. Why? Because integration of c derivative is just c, and we're just using definite integral. We are writing the top value and subtracting with the smaller value. Now they want to find the value of c20. So from here, I can say that c of 20 is going to be, you can add c of 12, you can bring it to the other side, or I would say add c of 12 on both sides. So this will be c of 12 plus, or you can first do integration and later add, it is your choice, but it's the same and same thing. So 12 over 20, negative 24.55 e to the power 0.01 t divided by t dt plus c of 12. C of 12 is given in the table. This integration we can find using the calculator, because graphing calculator is allowed, and we just have to add both of them and we will get our answer. Yeah. So now I'm going to use Desmos again. And in this particular time, we have to do this integration. So first, let's do that. For integration in Desmos, we just type int and you will get the integration sign. We will write 12 here and we will write 20 here, because we have to give the limits. And now over here, we will type the function. Let us check if we have done everything correct. It is negative 24.55. Yeah. Negative 24.55 e to the power 0.01 t over t dt. Perfect. And now we just have to check what is the value of c of 12. So from here, c of 20 would be equal to negative 14.6708. Negative 14.6708 plus, if you go back to the table, c of 12 is 55. So we will be adding 55. So temperature at 20 minutes is going to be, now I can just add 55 to it. And the answer is 40.329. So it is 40.329 degrees Celsius. And always write the approximate sign. Because this integration is also approximate. You can also call it 40.33 degrees Celsius as well. But so far, this is my answer. Yeah. So this is the entire work for part C. Show the setup for your calculations. We have also shown that. And find the temperature of coffee at time t is equal to 20. We have also done that. It is 40.329 degrees Celsius. So in the last, you can also say the temperature at 20 minutes is 40.329 degrees Celsius. The temperature at t is equal to 20 minutes is approximately 40.329 degrees Celsius. Got it? Now there's one more part, part D. So again, we can get rid of the decimals. Yeah. For the model defined in part C, C derivative was given to us. C double derivative of t is 0.2455 e to the power 0.01 t times 100 minus t divided by t squared. And this is for 12 is less than t is less than 20. That means t is between 12 and 20 minutes. Determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. So decreasing rate means concave down, increasing rate means concave up. And if double derivative is positive, it becomes concave up. If double derivative is decreasing, then it becomes concave down. So we just have to find out between 12 to 20, the graph of C double derivative is positive or negative. So for this, we will use Desmos. We will type the equation. We will see the entire graph. And first, let me write down theory for it. So over here, increasing rate means concave up. Which requires that C double derivative of t has to be positive, that is greater than 0. And decreasing rate, I think I should. Yeah, this is more aligned. Yeah. And now decreasing rate means concave down. Which means that C double derivative has to be less than 0. And now C double derivative is given as negative 24.55 e to the power 0.01 t times 100 minus t over t. And time is from 20 to 12. Now if you see, 100 minus t is going to be positive because you're only going from 12 to 20. So 100 minus t is a positive number because t is less than 100. T is also positive. Oh, it's 0.2455. Okay. And it has become positive. So 0.2455. Yeah. So 0.2455 is a positive number. E to the power anything is also positive number because y is equal to 0 is the asymptote. So it is going to be above 0. So it's also positive. 100 minus t, as I told you, it's also positive because it is from 12 to 20, the time. And t is also positive because again it is from 12 to 20. So the entire C double derivative is going to be positive. And C double derivative is positive from 12 to 20. That means what? It has to be increasing rate because it has to be concave up. So positive double derivative means C of t, that is temperature of the coffee, is changing at an increasing rate. the temperature of the coffee is changing at an increasing rate. And I think this should make much more sense. Okay, but we will also confirm this by using the Desmos. So we will use Desmos. And for this part, I will be using the full extent of it because I also want to see the graph. And I think I can use it over here. Hmm. Yeah. Hmm. So now we'll type C double derivative of t. So I will just write g of t because, yeah, and that is given as 0.2455 e to the power 0.01 t times 100 minus t divided by t. And now if you see the graph from 12 to 20, you see it's positive, just like I told you. So again, you can see from 12 to 20, the graph is positive because it is above x-axis. Okay. So because C double derivative is positive, that means it is changing at an increasing rate. Let me just write the correct spelling for coffee. I forgot an E. So you had to give a reason for your answer. We have given the reason as well. And with this, the part one, the question number one is finished. Now the second question is remaining. So now let's go into the second question. This is the second question. Also, one more thing, if somebody wants these solutions, those solutions are there at the college board. I will post those links as well. But even then, if you want my solutions, you can write in the comments or you can just DM me on Instagram, and I will provide you the solutions over there. Now, the second question. So the second question states that a particle moves along the x-axis. So this is your motion questions. Motion questions means what? Particle motions. So particles will have a position, they will have velocity, and they will have acceleration. So these are position, velocity, acceleration problems. So velocity is given by ln t squared minus 4t plus 5 minus 0.2 t. Now there is one time t is equal to tr in the interval 0 to 2 when the particle is at rest. That is, it is not moving. So particle will be at rest when the velocity is 0. It will not be moving when velocity is 0. So we have to find tr, and then we have to find out from 0 to tr, is the particle moving to the right or to the left? t squared minus 4t plus 5 minus 0.2 t. Yeah. So now in part A, particle is at rest. So particle at rest means velocity is 0. So at t is equal to tr, v of t is equal to 0. So what we will do, we will make the velocity 0, find the value of t, and that is going to be your tr. So we just have to do ln t squared minus 4t plus 5 minus 0.2 t is equal to 0. So for this, we will be using Desmos because graphing calculator is allowed. T squared minus 4t plus 5 minus 0.2 t. And this is from 0 to 2. So it is also becoming 0 at 2.8832, but we will not consider that because the question clearly states from 0 to 2. So the value should be greater than 0 but less than 2. So the correct answer is 1.42561. Okay. So from here I can say 1.42561. So TR can be approximately 1.43 or 1.426. Let's round to the thousandth place. 1.426. And they haven't told the time is in seconds or hours or minutes, so we will not write any units for this. And they're also not asking for any units in the question. So TR is 1.426. Now there's one more question. From 0 to TR, is the particle moving to the right or is the particle moving to the left? So for that, we know that position is integration of velocity. Or velocity is derivative of position. So if the position is positive or negative, we cannot know anything. But if position is increasing, then the velocity has to be positive. Okay. And if position is decreasing, then velocity has to be negative. So we just have to see if the velocity is positive or negative to identify whether it is increasing, that is going from left to right, or if velocity is negative, then it will be going from right to left. So over here, if you look at the graph, from 0 to TR, it is positive. Correct? This is above 0. So because from 0 to tr, the velocity is positive. That means the particle is moving from left to right because the particle position is increasing. So I will just write that now. Because v of t is greater than 0 or v of t is positive, for 0 to tr, the particle is moving to the right. All right. Because velocity is positive, particle is moving to the right because the particle's position is increasing. So that is about the part A. You have to give a reason for your answer. So the reason is because velocity is positive, it is moving to the right. If velocity is negative, it will be moving to the left. Now the next thing is part B. It states that find the acceleration. So acceleration is differentiation or derivative of velocity. Hmm. Yeah. So now acceleration is derivative. So A of t is going to be v derivative of t, or you can also say dv over dt. So first we'll find the formula. So acceleration is d over dt of ln t squared minus 4t plus 5 minus 0.2t. So let's solve it. So it'll be d over dt of ln t squared minus 4t plus 5 minus d over dt of 0.2t. For ln, it is 1 over t squared minus 4t plus 5. And we'll apply the chain rule as well. Differentiation of t squared minus 4t plus 5 is going to be 2t minus 4. And derivative of 0.2t is just 0.2. So this is the acceleration formula. 2t minus 4 over ln, 2t minus 4 over t squared minus 4t plus 5 minus 0.2. And now we have to find the acceleration at t is equal to 1.5. So now we'll be using the calculator. With the help of Desmos. Now because we just want the value, we do not want the graph. And it is 2, t is 1.5. Let me just write t is equal to 1.5, it will become easier. 2t minus 4 divided by t squared minus 4t plus 5 minus 0.2. It's negative 1. -1. And again, the units are not given for velocity, so we cannot find the units for acceleration as well. So acceleration at time t is equal to 1.5 is -1. Now, the next thing they want to know is whether the speed is increasing or decreasing. So over here, when you want to know about speed, then you have to look at these signs of both velocity and acceleration. If both velocity and acceleration are of the same sign, that means if both of them are negative, then velocity is increasing. If both of them are positive, then also velocity is increasing. If they are of opposite signs, that means velocity is increasing, but acceleration velocity is positive, but acceleration is negative. That means the velocity is decreasing. Or the opposite also is true, that if velocity is negative but acceleration is positive, then also velocity is decreasing. All right. So acceleration is -1. So now we just need to find out what is the value of v at 1.5. So for that, I will just write ln t squared minus 4t plus 5 minus 0.2t. It is also negative. Velocity is also negative 0.076. So over here I am writing, since both velocity and acceleration are negative, that is have the same signs, velocity is increasing. So that's our second question entirely. And if you want to see the graph also, so let me show you the graph. This is v of t. (1.5) is somewhat over here. So if you see, the magnitude of velocity is increasing only. Okay, that is why the velocity is increasing. It is increasing in the opposite direction, but it is still increasing. All right. Yeah. So to identify whether position is to the right or to the left, it only depends on velocity. It depends whether it is positive or negative. Now for velocity to be increasing or decreasing, it depends on both velocity and acceleration. If both have the same sign, it is increasing. If both have opposite signs, then it is decreasing. Okay, now the C part is asking for the position of the particle at time t is x of t, and its position at time t is equal to 1 is x of 1 is equal to -3. Find the position of the particle at time t is equal to 4. So position is integral of velocity. X of 1 is given. So at t is equal to 1, you have to find at t is equal to 4. So what you can see x of t is integral of v of t dt plus c. X of 4 will be 1 to 4 ln t squared minus 4t plus 5 minus 0.2t dt plus x of 1. Okay. And now to find the integral, you can again use Desmos. But over here, we just need the value, so there will not be any need for the graph. So integral from 1 to 4 ln t squared minus 4t plus 5 minus 0.2t dt, and I will put the parentheses over here. This is 0.197. And what is x of 1? It is negative 3. So we'll be subtracting 3. Negative 2.80288. So negative 2.803. So at t is equal to 4, position of the particle is at negative 2.803. Okay. And that is it. We're done with this question. So you just need to know that position is integration of velocity. In velocity, we are integrating from 1 to 4. And velocity is given by ln t squared minus 4t plus 5 minus 0.2t. Now the last portion, that is find the total distance traveled by the particle over the interval 1 to 4. So now distance is not negative. Even if you understand this thing, if you're going like this and if you're coming back, position will be 0 or position will be negative, but distance will not be negative. You have to add all the distances together. If this is 2, this is 2. If you're going 3 back, the total distance is 5. So we're taking the absolute value of the integral. Okay. So in part D, you have to find out the total distance. So the formula for total distance is integration 1 to 4, absolute value of v of t dt. Because it doesn't matter whether you're going back, you're moving forward, all that matters is that you have to add all the distances together. So now we'll just do that on Desmos. So again, this is integral from 1 to 4, and it is absolute value of ln t squared minus 4t plus 5 minus 0.2t dt. It is 0.958. So the total distance traveled from time is equal to 1 to time is equal to 4 is 0.958. Zero 0.958 over the interval t is equal to 1 to 4. Got it? See, if you do not put the absolute value, then it will be telling you the position. And position can be, you can move to the left, you can move to the right. So if you remove this, you should get a smaller value, 0.19, because you're moving back and forth. So that is why it is important to put the absolute value so that you can get the total distance traveled, and that is 0.958. Yeah, and now with this, part A is complete. We have done both question number 1 and question number 2. Now let's just identify the questions were asked from which unit, like what was the topic. So if I go back to the first question, average rate of change, that is from differentiation. Then you have to find left Riemann sum, that is from the integrals topic. And meaning of 1 over 12, that is again your integrals topic. Then you're also trying to find out the temperature, that is from definite integrals. The second was accumulation of sums. Okay. Third is your definite integrals. And the fourth one is actually differentiation only, but application of differentiation, where you can find the relationship between the function and its first and second derivative. It is coming from there. So it is all from integration and differentiation. Limits and continuity do not play a very important part over here. But the only thing that was important was to note that it is decreasing differentiable function. Only then you were able to find the average rate of change. Because at t is equal to 5, the value will be between 85 and 69. That comes from MVT, the mean value theorem. Now the second question, this is again your particle motion. So in option A, we are just solving for velocity. Particle is moving to the right or to the left. That is also coming from the relationship between the function and its derivatives. The acceleration you have to find out, that is differentiation. And the position of the particle, that is integration. Total distance is again integration. So it is again from differentiation and integration. So this was the end of part A. Now we'll be starting with the part B. But before that, I'll take a quick break and I'll be right back. Hi. Yeah, I'm really sorry. I forgot to unmute myself. Yeah. So now we'll be starting with the second section, part B. It is for 1 hour, and we have to do 4 questions. So we'll be here for more 1.5 hours because explaining takes a little more time than just solving it. So let's dive into it. The question number starts from question number 3 because the first 2 questions were part of part A. And let's see if there are some instructions that you cannot go to the section unless you finish the previous one. No, nothing like that. You just have to write your answers in a free response booklet. So you have to write your solution to each part in the space provided for that part. So next time I will try to get the free response booklet so that we have an idea how many spaces given to you. Time. Wasting time. We will continue. So yeah. Part B, question number 3. There is some issue with the laptop. Oh my god. Not audio. Why is it showing that audio? I have no idea what it is trying me to do. I can't even go to the settings. I don't know what is the issue with the audio. I tried to fix it, but it is still showing that there's some problem again. I will not focus on that. Now, question number 3. And now it has started working. So, the depth of seawater at a location can be modeled by the function h that satisfies the differential equation. So, now one question from differential equation. It was not there when we were doing the calculator section. So dh over dt is half h minus 1 cosine t over 2, where h of t is measured in feet and t is measured in hours after noon, t is equal to 0. It is known that h of 0 is equal to 4. So at noon, we're considering time as 0. A portion of the slope field for differential equation is provided. Sketch the solution curve y is equal to h of t through the point 0, 4. So the starting point is given to you 0, 4. Okay. Um, I wish I had some extension. Just give me a second. Because the college board PDFs, they do not allow me to type anything over here. So I'm just seeing if I can get any extension. I am not able to use it. No, I can't do it. Yeah, I think I've got it. Just give me one more second. Yeah. Sorry for the delay. So over here, because it was easier for me to like draw it over here itself. So let me first get it. And I'll be using Zoho. I'll capture the entire screen. Can you see it? Yeah. Perfect. And now, so when you have to draw the graph, it is like this. It's starting from here. So you just have to travel across the the slopes. So it'll be like this. So let me try it one more time. So we're going like this, we're going like this, we're going like this. And then we go like this. So this is how it will look like. Got it? So this is the answer for the question. Like this is the slope line. Okay? So look something like that. So you just have to connect through all the dots. Sorry. And now that is it. We are done with the part A. In the part A, you just have to do that. You just have to sketch the solution curve that we have done. So it starts from here and you just keep connecting the dots. Now we'll start with part B. From 0 to 5, it can be shown that h of t is greater than 1. Find the value of t. Now we'll be using our whiteboard. Question number 3, part B. And it's good because now I can write. For example, when we were doing MCQs, I was not able to write on the document. Now we can do that. Yeah. So for 0 less than t less than 5, h of t is greater than 1. Find the value of t at which h has a critical point. So critical point occurs when the derivative is 0. Alright. And derivative means what? The numerator can be 0 or denominator can be 0. So the derivative is either 0 or undefined. So that is your critical point. And then you have to identify whether the critical point corresponds to a relative minimum or relative maximum or neither. So let's go ahead. For that, I would need to see the question and write whatever is given to us. Yeah. So before part B, I will just write dH over dt is given as 1/2 h minus 1 cosine t over 2. And then h of t is in feet, t is in hours, and h of 0 is 4. Now we are ready to solve the B part. Yeah, for 0 to 5, h of t is greater than 1. That means h minus 1 cannot be 0. Okay? So determine whether, so we have to find the critical point. Critical point is where derivative is 0. One half h minus 1 cosine t over 2 is equal to 0. Half cannot be 0, so what we can do? From here there's only two possibilities. Either h minus 1 can be 0, but we know that h is greater than 1. That means h minus 1 is greater than 0. So if h minus 1 is greater than 0, then this means that only cosine t over 2 is going to be 0, because you can divide by half h minus 1, because none of them is 0. So cosine t over 2 is equal to 0. And now t is from 0 to 5. So if t is from 0 to 5, that means t over 2 can be pi over 2. Cosine is 0 at pi over 2, right? So from here you will get t is equal to pi. It is also 0 at 3 pi over 2, but from there you will get t is equal to 3 pi, and that is greater than 5 because the value of pi is 3.14. So that will be approximately 9 point something. So at t is equal to pi, you are getting a critical value. Okay. So h has a critical point at t is equal to 3.14, or you can also write t is equal to pi. Now, if you look at the slope fields, you can see there is a relative maximum over there. If I show you over here, approximately 3, you're getting the maximum. Okay. But now how can we determine it over here? So for that, we can use either first derivative test or the second derivative test. So now this is your critical point pi. And this is the graph of cosine, because only cosine t over 2 is identifying whether it is going to be positive or negative, because half is positive, h minus 1 is positive, because we have shown that h minus 1 is greater than 0. So cosine t over 2, at 0 the value is 1. So before pi it is positive, after pi it is negative. So the dh over dt value is, the first derivative is going from positive to negative. That means it is a relative maximum, because the function is going from increasing to decreasing. This is how the function will look like. First derivative is changing from positive to negative. Hence, the critical point at t is equal to pi has a relative maximum. Okay. So the critical point corresponds to a relative maximum. So I can also just write that the critical point corresponds to a relative maximum. And this is the graph of cosine t over 2. No calculator is allowed, so all the calculations you'll have to do, or all the graphs you'll have to make by yourself. Or what we can do, the second thing that can be done is second derivative test. So to get second derivative test, what we will have to do? Now dh over dt is given as 1/2 h minus 1 cosine t over 2. So first we'll have to apply the product rule. So first we'll take derivative of h minus 1, it will be dh over dt times cosine t over 2. 1/2 h minus 1 will remain as it is. And differentiation of cosine is negative sign. So it will be negative sine t over 2. And you'll also have to multiply with 1/2 because we are doing the chain rule. Okay. So now we know that at t is equal to pi, cosine t over 2 is 0. And sine of t over 2 will become pi over 2, which is 1. So that is why d2h over dt square, it would be, there's a negative sign, negative 1/4 h minus 1. And because sine t over 2 value is 1, I'm writing 1 over here, this becomes 0. So this entire term becomes 0. Okay, so it's just negative 1/4 h minus 1. And h minus 1 is greater than 0. That means your second derivative is negative. Now, since second derivative is negative, at critical point, so the critical point corresponds to a relative maximum. If second derivative would have been positive, it would correspond to a relative minimum. And how can we come to this conclusion? Because second derivative is negative, that means it is going to be concave down. And this is a graph of concave down. And in concave down, you always get a maximum. That is how I remember it. Because you'll also have to remember lots of things. So how do I remember it? Because second derivative is negative, that means it is concave down. You make the graph of concave down, and when you make the graph of concave down, it is always, you're always having a maximum. That is why this point corresponds to a relative maximum. Got it? So so this is the entire thing. This is the second derivative test. Okay, that we are applying to see if it is a relative maximum or minimum. But you can also apply the first derivative test. You just have to, because at critical point it is going to be 0, you just have to see whether you're going from positive to negative or negative to positive. And if both the signs were same, then there will be no relative maximum or minimum. So that also, if you see, we have done over here. Got it? Yeah. So now part C, you have to use separation of variables. Yeah, that is it. The part B is completely done. I've told you both the methods through which you can identify whether it is relative maximum. First is first derivative test. Critical point is t is equal to pi. The only deciding factor is going to be cosine t over 2 because h minus 1 is positive, half is positive. So they're not going to make it negative. Okay. So we'll have to check the graph of cosine t over 2. We know the normal standard graph. Before t over 2, that is pi over 2, it is positive. After it is negative. So we are going from positive to negative. That is why it is relative maximum. Because it is increasing, then it is decreasing. Now in part C, we have to use separation of variables. So let's do that. Use separation of variables to find y is equal to h of t, the particular solution to the differential equation with the initial condition h of 0 is equal to 4. So dh over dt is equal to 1/2 h minus 1 cosine t over 2 yeah, And now, so separation of variables, I will bring h minus 1 in the denominator over here. Half cosine t over 2 will remain over here and dt will come here. And now we are going to integrate on both sides. Because it is 1 over h minus 1, this is going to be ln h minus 1. And t over 2 you can take as u. So dt over 2 will be du. So this will simply become cosine u du. And now, because since h minus 1 is positive, that is why absolute value of h minus 1 is just going to be h minus 1. So now ln h minus 1 is integration of cosine is sine, so it will be sine u plus c ln h minus 1 is equal to sine t over 2 plus c. Now h of 0 is 4. So that is why ln 4 minus 1 is equal to sine 0 plus c. From here, ln 3 is going to be c because sine 0 is 0. So c is equal to ln 3. And now you can write the function. Ln h minus 1 is equal to sine t over 2 plus ln 3. I will bring ln to the other side so that I will be able to combine the ln's because I want to write h. Like I want to solve for h, simplify for h. Ln h minus 1 minus ln 3 is equal to sine t over 2. Because logs are subtracted, arguments will be divided. Ln h minus 1 over 3 will be sine t over 2. And from here, you can take antilog. H minus 1 over 3 will be e to the power sine t over 2. And that is why h minus 1 will be 3 times e to the power sine t over 2. There is one more way of doing this, and then you add 1. So finally, h of t will become 3e to the power sine t over 2 plus 1. And for this one, I will make it, let me see if I can make it bigger. No, I can't. So I'll make it smaller so that you can see the entire solution. I think we can. Yeah. So this is entire part C, dh over dt is equal to 1/2 h minus 1 cosine t over 2. We are integrating dh over h minus 1 is equal to 1/2 cosine t over 2 dt. dh over h minus 1 will simply become ln absolute value of h minus 1. Over there, I'm considering t over 2 as u. So dt over 2 will become du. So half times dt is du. So that is just du, and cosine t over 2 is u. So it has become cosine u du. And because h minus 1 is positive, it is given in the question that h is greater than 1. So because h minus 1 is positive, then absolute value of h minus 1 can be written as just h minus 1. So ln h minus 1 can be written as sine u plus c. So you can write ln h minus 1 is equal to sine t over 2 plus c. Now you can do two things. You can first simplify for h and then find the value of c. Or in the second case, first we are finding the value of c and then we are solving it. So we are doing ln h minus 1 is equal to sine t over 2 plus c using the initial condition h of 0 is equal to 4. We are finding the value of c, that is ln 3. So ln h minus 1 is sine t over 2 plus ln 3. I'm bringing it to the other side. It is becoming ln if, okay. Now I will just show you the different ways that you can solve it. this should look like capital H. Yeah. So now instead of bringing it over here, what I could have done? I could have directly taken the antilog. So H minus 1 would have become e to the power sine t over 2 plus ln 3. From there, you will get H minus 1 is equal to e to the power sine t over 2 times e to the power ln 3. And e to the power ln 3 is just 3. So from here, you can come back here. H minus 1 is 3 times e to the power sine t over 2, add 1, and you're getting your solution. That is another variation that you could have done. All right. There's one more variation that you could have done. So I'll show that variation as well now. You will still get final answer the same, but you can just take detours. So now instead of finding initial condition over here, we'll first solve for H. So I will be saying H minus 1 is equal to e to the power sine t over 2 plus c. That would be H minus 1 is equal to c times e to the power t sine t over 2. Because this would become this is also a constant, so I can replace it with c. Now H is equal to c e to the power sine t over 2 plus 1 because you're adding 1 on both sides. And now you use H of 0 is equal to 4. So 4 is equal to c e to the power sine 0. 4 is equal to c plus 1, and this will give you c is equal to 3. Because why? Because sine 0 is 0, e to the power 0 is 1. Or if you want, you can write it like that as well. E to the power 0 plus 1, that means c plus 1 is equal to 4, c is equal to 3. And again, you will get the exact same answer. H of t is equal to 3e to the power sine t over 2 plus 1. You can use this method also. So you can use whichever method you find the best. All right. I will keep this method and we'll move to the next question. So the third question is now complete. Now we'll move to the next question, that is question number 4. This is the graph that is given to us, and let's see what the question is asking. Yeah. So the graph of the differential function is shown for negative 6 to 7. It has a horizontal tangent at x is equal to negative 2, and it is linear for 0 to 7. Okay, now I also want the graph at all times to be seen. So let me do a little thing over here. Yeah. So over here, I'll keep it like this. I will add another window capture. No, I don't want this. Just give me a second. I'm just doing the settings. Hmm. Yeah, because there are no comments, so I can just keep the diagram over here because I'll be needing it. Now we are ready. So you can see the diagram at all times. Hmm. I think I can make it even smaller. Hmm. Better. So now we can start with the question. It is a differentiable function from -6 to 7. We can see that. It has a horizontal tangent at x is equal to -2. So we can see that at x is equal to -2, there is a relative maximum. So there is a horizontal tangent. It is linear from 0 to 7. So we can see that from 0 to 7, the graph is linear. Now R is a region enclosed in the second quadrant, bounded by the graph of f. The vertical line x is equal to -6, and the x-axis and the y-axis. Region R has area of 12. The function g is defined by g of x is equal to integration from 0 to x f of t dt. Find the values of g of -6, g of 4, and g of 6. So g of x is integration from 0 to x f of t dt. So first we are finding g of -6. That is, we are going from 0 to -6 f of t dt. And we'll apply the properties of definite integrals because this question is coming from definite integrals. So minus, when you change the limits, you introduce a negative sign. -6 to 0, negative f of t dt. And now if you look at the diagram, from -6 to 0, it is the entire region R. Okay? So this entire integral is going to be R, and the value of R is given to us as 12. So this entire thing is R. So this is -R, -12. So the first answer is -12. Now we have to find g of 4. G of 4 will be from 0 to 4 f of t dt. Now we know that 0 to 7 is a linear function. So 0 to 4 is actually a triangle. If you look at the triangle, base is 4, height is 2. Because definite integral is also the area. half BH, half times 4 times 2. The answer is 4. So G of 4 is 4 because this is 4, this is 2. Okay? So 4 times 2 is 8, 8 divided by 2 is 4. You could have directly cancelled 2 and 2 and the answer would have been 4. So let me do that. Because definite integrals are just the area. So if we can find the area, good enough. It's a triangle, so area is going to be half times base times height. Now next you have to find is G of 6. So that means you're going from 0 to 6 f of t dt. Now we have already, from 0 to 6, there are two different triangles. The one is above x-axis, the second one is below x-axis. So here what we can do, we can write 0 to 4 f of t dt plus 4 to 6 f of t dt. Now 0 to 4 from the previous one, we can say 4 minus, from 4 to 6, why it is going to be minus or negative? Because it is below x-axis. It is downwards. So over there, if you see, the base is 2 because you're going from 4 to 6. Height is 1 because it is 6 comma negative 1. So you're going from 0 to negative 1. So that is 1. So this would be half times 2 times 1. That is just 1. So it is 4 minus 1, which is 3. So the third answer is 3. First answer is negative 12 because it is just the opposite of, like, instead of going from here to here, we are going from here to here, 0 to negative 6. That is why it is negative 12. Now 0 to 4, that is a triangle, half times base times height, half times 4 times 2, that is 4. And now G of 6, you're going from 0 to 6. So from 0 to 4, the area is 4. Now we have to find from 4 to 6, that is going to be a negative area. Why negative area? Because it is below x-axis. So their base is 2, height is 1. So that area is negative 1. 4 minus 1 is 3. Okay. So G of 6 is 3, G of 4 is 4, G of negative 6 is negative 12. Part A is done. Now we will move to the second part. Second part is saying that for the function G defined in part A, find all values of x in the interval 0 to 6 at which the graph of G has a critical point. So now graph of G has critical point where G derivative of x is 0. Got it? Because critical points are where derivatives are 0. So G of x is integration of 0 to x f of t dt. So gx is integration of f, so its derivative is just going to be f of x. So from here, by applying the law of antiderivative, g derivative of x is just f of x. Okay? So g derivative of x is f of x. So we just have to see where f of x is 0 to find the critical points. From the diagram, we can see f of x is 0 at 4. Is 0 at 4 from the graph. Hence, G has a critical point at 4. That will be your answer. And you want to know only from 0 to 6, so 4 is the only point. Alright? And we will always say that t is from 0 to 6, we'll write all the conditions. That's about the second part. Derivative of g is just f, and for critical we have to find where derivative is 0. That means we have to find where f is 0 at 4. Now the third part of the question, and you have to find all values of x, so there's only one value of x. Third is the function h is defined by h of x is equal to -6 to x, f derivative of t dt. So you have to find the value of h of 6, h derivative of 6, h double derivative of 6. Okay. H of x is -6 to x, f derivative of t dt. So first you have to find h of 6. It will be from -6 to 6, f derivative of t dt. Now integration of f derivative is just going to be f. So this is going to be f of 6 minus f of -6. And now from the graph, you can see that h of, like f of 6 is -1. And at -6, it is 0.5. So h of 6 is -1.5. Now you have to find h derivative of 6. So before getting h derivative of 6, we'll just see what is h derivative of x. Now h is integration of f derivative. H derivative is simply going to be f derivative of x. Got it? So from here, h derivative of 6 is going to be f derivative of 6. So now we have to find f derivative of 6. So for that, since f is linear from 0 to 6, 0 to 7 in fact, from x is equal to 0 to x is equal to 7, f derivative of x is equal to slope. Correct? Because for linear function, slope is constant, that is f derivative is constant, and we can find that out. It is going to be 6, -1. And at 0, the value is 2. So -3 over 6, that is -1/2. So, yeah. So f derivative of x is equal to -1/2 over 0 to 7. I will also show you one more method. This is -1/2. Or what you could have done, we know that h derivative of x is equal to f derivative of x. F of x is linear. So y-intercept is 2. And we have to find the slope. Slope we have already found that it is -1/2. Because you have 0, 2 and 4, 0. So 4 over 2, like 2 over 4, -1/2, okay? Because from 2 you're going 2 down and 4 to the right. So -2 over 4, -1/2. So f of x is going to be -1/2 x plus 2. That is why f derivative of x is just -1/2. Got it? So h derivative of 6 is -1/2. Now we have to find h double derivative. So from there, we know that h double derivative of x is going to be f double derivative of x. That means h double derivative of 6 is 0 because f double derivative of x is 0. Over 0 to 7. Got it? So h of 6 is negative 1.5. H derivative of 6 is negative 1/2. And h double derivative is 0. Alright, and with this, the second question is also over. Now we'll go back. Now we'll go to the next question, that is question number 3. Question number 5, third question, because the question started from third question. So question number 3 over here is question number 5. And now I don't need this graph, so I will just, get rid of it. Now question number 5 is, consider the curve defined by the equation x squared plus 3y plus 2y squared is equal to 48. It can be shown that dy over dx is equal to negative 2x over 3 plus 4y. There is a point on the curve near 2, 4 with the x coordinate 3. Use the line tangent to the curve at 2, 4 to approximate the y coordinate at this point. So let's write everything. X squared plus 3y plus 2y squared is equal to 48. Dy over dx is equal to negative 2x over 3 plus 4y. So there is a point on the curve near 2, 4. So if we look at 2, 4, when x is equal to 2, 2 squared is 4. 3 times 4 is 12. 12 plus 4 is 16. 16 plus 32 is 48. So 2, 4 also passes through the curve. X coordinate is 3. Use a line tangent to the curve at 2, 4 to approximate the y coordinate of this point. Alright. So 2, 4 is given to you. Alright. So from here, when the point is 2, 4, dy over dx is going to be negative 2 times 2 over 3 plus 4 times 4. Negative 4 over 19. And 2 squared plus 3 times 4 plus 2 times 4 squared. 4 plus 12 plus 32. 48. 2, 4 is on the curve. So now equation of tangent line at 2, 4 would be this is the slope. Y minus y1 is equal to m times x minus x1. So y minus 4 is equal to negative 4 over 19 times x minus 2. So y is equal to negative 4 over 19 x minus 2 plus 4. Okay. Now you have to find the y coordinate when x coordinate is 3. So at x is equal to 3, y will be negative 4 over 19 plus 4 because 3 minus 2 is 1. So negative 4 over 19 plus 4 over 1. So negative 4, 19 times 4 is 76 over 19. So y is going to be 72 over 19. That is our answer. Because you have to use a line tangent to the curve. So line tangent is y is equal to negative 4 over 19 times x minus 2 plus 4. All right, the entire question you can see over here. At 2 comma 4 dy over dx. Let me write that. At 2 comma 4 dy over dx is negative 2 times 2 over 3 plus 4 times 4. That is negative 4 over 19. That is the slope. Check if 2 comma 4 is on the curve. So we have checked if the point is on the curve or not. So it is on the curve. Now equation of tangent line y minus y1, or you can directly use this also. It will save one step. So you would not have to write it again. And now at x is equal to 3, y will be negative 4 over 19 plus 4, because 3 minus 2 is 1. So that is negative 4 plus 76 over 19, that is 72 over 19. And that is what you had to find, the y coordinate of this point. Approximate y coordinate is 72 over 19. This question is done. Now the second part is the horizontal line y is equal to 1 tangent to the curve? Is the line y is equal to 1 tangent to the curve? For horizontal line to be tangent, the derivative has to be 0. Okay. So when y is equal to 1, the equation is x squared plus 3y plus 2y squared is equal to 48. X squared plus 3y plus 2y squared. So when y is equal to 1, x squared would be plus 3 plus 2 is equal to 48. X squared will be 48 minus 5. X squared is 43. And that means x can be plus or minus square root of 43. Now we'll find dy over dx. It should be 0. It is negative 2x over 3 plus 4y. So negative 2 times plus or minus square root 43 divided by 3 plus 4, and this is not equal to 0. Since dy over dx is not 0, y is equal to 1 is not the tangent. Got it? So now I will just make it a little smaller so that you can see the entire solution. Yeah. So for horizontal line to be tangent, first derivative dy over dx should be 0. So when y is equal to 1, we find the value of x. It is plus minus square root of 43. And when y is equal to 1, x is equal to square root of 43, dy over dx is not 0. That means y is equal to 1 cannot be tangent to the curve. Got it? So we have given the reason, we have given all the explanation. Now the third part, the curve intersects the positive x-axis at the point square root 48, 0. Is the line tangent to the curve at this point vertical? So at square root 48, 0, because both points are directly given to you, you can directly find dy over dx. 3 plus 4y. Yeah. So this would be negative 2 square root of 48 over 3, because 4 times 0 is 0. So getting negative 2 square root 48 over 3. For the tangent to be vertical, for a vertical tangent, dy over dx should be undefined. That is, the denominator should be 0. But at square root 48, 0, the denominator of dy over dx is 3, not 0. Hence, the tangent cannot be vertical. Cannot be vertical. So that is the entire solution for part C. Okay, because dy over dx is negative 2x over 3 plus 4y. 3 plus 4y is not 0, because denominator should be 0, and the vertical line is not the tangent. The line tangent to the curve is not vertical. So that is part C. There's one more part for question number 5. And that is that for time t greater than or equal to 0, a particle is moving along another curve defined by the equation y cube plus 2xy is equal to 24. At the instant the particle is at the point 4, 2. So 2 times 4 times 2, 4, 4, 16. 16 plus 8, 24. Yes, it does work. The y coordinate of the particle's position is decreasing at a rate of 2 units per second. Decreasing, that means it is negative. At that instant, what is the rate of change of the x coordinate of the particle's position? So for option D, the curve is y cubed plus 2xy is equal to 24. This is what is given to us. The next thing that is given to us is the point is 4, 2. That means x is equal to 4, y is equal to 2. Next thing that is given is y coordinate is decreasing at a rate of, so dy over dt is given to us. Negative 2 units per second, because it is decreasing. Alright. And now what you have to find out? Again, I don't know why this laptop is behaving in such a way. Let me come to the sound. Yeah. You have to find out dx over dt. And now we'll do the solution. Y cubed plus 2xy is equal to 24. Derivate on both sides. Y cubed is 3y squared times dy over dt. We are differentiating with respect to t. Over here, we'll have to apply the product rule. So 2 times dx over dt times y plus 2x times dy over dt, and differentiation of 24 is 0. Now we'll just plug in y is 2. So 3 times 2 squared times negative 2 plus 2 times dx over dt plus 2 times 4 times negative 2 is equal to 0. The value of x is 4, value of y is 2, is negative. Yeah. So 2 squared is 4, 4 times 3 is 12, 12 times negative 2 is negative 24, plus 4 dx over dt, 8, negative 16. So 4 dx over dt will be 24 plus 16, which is 40. That means dx over dt is going to be 10. So what they're asking, rate of change of x with respect to time is increasing by 10 units per second. Why it is increasing? Because it is positive. This is our answer. Or you can say it is increasing at a rate of 10 units per second. But basically, this is the answer. Yeah, and with this, fifth question is done. Now the last question, the fourth question of part B and sixth question of the entire module is remaining. So now we'll do that. So here again, you have a diagram and there are a lot of questions. So we want to keep the diagram. So again, I'll open it up and move to this diagram. I'll have to move it little. Yeah, now you can see the entire diagram. And now we can move to the questions. Okay, so the first part is let R be the region. Bounded by the graphs of f and g from x is equal to 0 to x is equal to 2. 0 to 2, okay, that is R, correct. Right, but do not evaluate an integral expression that gives the area of the region R. So you're going from 0 to 2 and you can see f of x is on top, g of x is on bottom. So you're going from x is equal to 0 to 2, f of x minus g of x dx. Why we are saying that? Because you can see we are taking small intervals of dx. So the width is dx, but the height is going to be f of x minus g of x. Okay. Because f of x is on the top and g of x is on the bottom. So the height or the length is going to be f of x minus g of x. Width is dx. And we are finding the area. So area of small rectangles is going to be length times width. Length is f of x minus g of x. Width is d of x. I'll show you over here the diagram as well. So you're having small segments like this. So this is dx and this is going to be f of x minus g of x. And it is the area. So area is length times width. That is f of x minus g of x times dx. And you're taking all these areas from 0 to 2. That is why we're doing the integral. Now f of x is how much? F of x is x squared plus 2. G of x is x squared minus 2x, will be minus x squared plus 2x. We do not have to evaluate, we just have to write it. So it's just 2 plus 2x dx. You can leave over here as well or you can leave over here as well. You just need to know because it is the area. You're making small rectangles. So area of each small rectangle is going to be length times width, that is f of x minus g of x times dx. And we're taking the summation of all those small rectangles. That is why we are doing the integration. Okay. Because we have to give the area of region R. So this is the expression. Now in part B, let S be the region bounded by the graph of G and the x-axis from x is equal to 2 to x is equal to 5 here. So it is just G from 2 to 5. Region S is the base of a solid. So we're talking about a solid. So if we talk about volume of solid, that means we're talking about the prism. Okay, because there is length, there is width, there is height, there is a base. All right. There is height and you have to find the volume of the solid. So now in part B, region S is the base of solid. That means base is going to be g of x. For the solid at each x, the cross section perpendicular to x-axis. So it is perpendicular to x-axis, that means it is in that direction. So this is x, this is y, and then you're going like this. Okay, so this is g of x. This is height, which is half of g of x because height is half times base. And now we're taking small sections, so width is going to be dx. Got it? So each small rectangle, it is having a width of dx, the length or the base of g of x, and height is because height perpendicular to this S or perpendicular to x-axis, that is a rectangle with a height equal to half its base in region S. So it's a rectangle, right? You have g of x and there you have rectangle. So d of x and half of g of x. Got it? I hope you understand. Because cross section is a rectangle, that is why it is going to be length times width times height, because rectangle is width is dx and height is half times g of x. Because perpendicular to x-axis is both y-axis and the z-axis. Now we have to find volume of the solid. So volume is going to be base times height times width. That is g of x times half of g of x times d of x. That is going to be dV, volume of this small portion. And that is half g of x whole squared dx. And the x value is going from 2 to 5. So you're going from 2 to 5, half g of x whole squared dx. G of x is x squared minus 2x. And over here you have to find the volume. You don't have to, you will have to evaluate because they're not saying that just write the expression. So now we'll solve the entire thing. Because the cross section was rectangle, that is why it is becoming sort of a prism, and it is just length times width times height. So now to integrate it, first I will open it up. It will become x to the power 4 minus 4x cubed plus 4x squared. I'm applying a squared minus 2ab plus b squared. A squared is x to the 4th, minus 2ab is minus 4x cubed, and b squared is 4x squared. I can keep half outside. So the integration of x to the 5th is going, x to the 4th is going to be x to the 5th over 5. 4x cubed is going to be just x to the 4th. Because x cubed is x to the 4th over 4, 4 cancels. So I'm just combining those steps. And 4x squared will be 4 times x cubed over 3. And you're going from 2 to 5. So first let me put 5. 5 to the power 5 over 5 minus 5 to the power 4 plus 4 times 5 cubed over 3. Minus 2 to the 5 over 5 minus 2 to the 4 plus 4 times 2 cubed over 3. 5 to the 5th over 5 is going to be 5 to the 4th. 5 to the 4th minus 5 to the 4th is just going to be 0. 5 cubed is 125. 125 times 4 is 250 times 2 is 500. Uh, 2 to the 5 is 32. So 32 over 5. This will become plus 16. This will become minus. 2 cubed is 8, so it will be 32 over 3. So let's first solve 500 over 3 minus 32 over 3. 500 minus 32 is 500. 100 minus 30 is 70. So it will be 468. Minus 32 over 5 plus 16. 468 over 3 is going to be 1. 16 is 5, 156. So let me take 1 now. I think the calculations will be easier then. 78 plus 8 minus 16 over 5. 86 minus 16 over 5. 86 times 5 is 430 minus 16 over 5. 414 over 5 cubic units. If you want, you can also convert it into decimal. So half 2 to the 5, it was half gx whole squared dx. Gx is x squared minus 2x, so its whole squared is x to the 4th minus 4x cubed plus 4x squared. So x to the 5th minus x to the 4th plus 4x cubed over 3. Then you're just putting 5 and 2. 125 times 2 is 250 times 2 is 500. 32 over 5 plus 16 minus 32 over 3. 500 minus 32 is 468. 156. Now I'm dividing all the numbers by 2. 78 plus 8 minus 16 over 5. 86 minus 16 over 5. 430 minus 16 over 5. 415 over 5. So that is it. This is our answer, 414 over 5 cubic units for part B. Now for part C, again, they do not want to evaluate, but just write the expression that gives the volume of solid generated when region S is rotated about horizontal line y is equal to 20. So when you are rotating something, it is going to become sort of cylindrical. Got it? So in part B, you have to be very, very, very careful of the calculations. So now I'll make the diagram. Okay, I'll make it little smaller because we have to rotate it as well. Because at 5 it is 15. Now your rotating means what? So this distance is 20, it will go up. And now the distance will. So now this is 40. And this is what you will get. And you want this thing. Okay? So over there also, it will be this region which you will be getting. Got it? So we have rotated it. Now if you see, we're rotating about this point, going like this, so we're making a circle. So when you're looking from this, you can see the cross section, that is going to be a circle. And there are going to be two circles because this entire circle Okay. And one circle making g of x. And we need this portion, as we can see from the diagram. So the radius of the bigger circle is 20, because this is 20 and this is 20. Now this forms the inner circle, correct? So the radius of the inner circle, that is small r, that is 20 minus g of x. Because this is graph of g of x. Alright. So like I told you, it's a cylinder. So it will be pi r squared minus r squared times height. And height is just going to be dx. Alright, because I'm making cylinder like this. So this is the radius part and this is the height part. And again, because it is bounded by region S, so we are going from 2 to 5. So we'll just write it. Pi will be outside. R is 20, so it will be 20 squared minus 20 minus g of x whole squared dx. That is your answer. Got it? Because it is like this and your graph is over here, you are rotating it like this. So this is becoming the circle part, but you just want this part. So you have the bigger circle and you'll have to subtract the inner circle from there. That is why you will get this part and this part. Okay? And this is the height. So that is why we're taking dx. Because we'll be having this section. So we are taking this section, then we are taking this section, then we are taking this section. So this height is going to be dx. Okay? This is your circle and this is going to be dx. So it's very important to visualize over here. And you don't need to evaluate it, you just need to write the integral expression. So this is your integral expression. If you want, you can simplify it a little bit, but no need. Because it is going to be like this, and this thing is dx. If you want, you can simplify it little much, but no need. This is your answer. So there are two methods in integrals, washer method and there's one more, disk method. So we'll also so if you know the theory from there, you can also learn it. But whenever you're revolving, it will become cylinders. Yeah, and with this, we have done all the questions. I hope I was able to explain everything, and that is end of exam. So there were total 6 questions. 2 had graphing calculators, 4 did not have any graphing calculator. So that is it. Thank you so much. We're done for today, and we did the FRQ for 2024. If you want to do more FRQs, please let me know in the comment sections. And also, like I told you before, if you want the solutions, like I have the entire PDF with me. So if you want the solutions, you can write on Instagram or DM me. You can DM me on Instagram, or you can write in the comments. I will provide you with these solutions. And I will also provide the links from the college board where you can see the solutions in the description. So yeah, that is it. We're done for today, and I'll see you soon. Thank you so much. And if you like my content, please do not forget to like, share, and subscribe. That's what every YouTuber says. So I'm saying the same thing. Thank you. Bye. Good night for Indian students and good morning to all the American students. Thank you.